Welcome back to another video. In this one we will be working question 1 for the 2019 Unit 2 paper. Alright, so question 1, it gave us this compound and tells us that we react it with sodium hydroxide to get an alcohol. So react this compound with sodium hydroxide and we get an alcohol. So the first part of the question, part A, part 1, is to name this compound, the type of reaction that occurs when this compound reacts with sodium hydroxide, and then to outline a mechanism for the reaction. So we're going to do that now. Name the compound, state the reaction, and outline the mechanism. Okay, so we have two methyl groups attached to a carbon. So two methyl groups attached to a carbon with a hydrogen, then carbon, bromine, methyl group, two methyl groups, a carbon, then a hydrogen, carbon, bromine, methyl group, CH2, CH3. So that's our compound. 1, 2, 3, 4, 5. No. So we're supposed to have 1, 2, 1, 2, 3, 4, 5, 6. This is a substituent group. One of these is a substituent group. So we have 1, 2, 3, 4, 5, 6 carbons. That is hexane. We have bromo and 2 methyl groups. Clearly, they are closer to this end, so we start counting from this end. So 2 methyl groups, that would be dimethyl. They are on carbons 2 and 3. 2, 3, dimethyl. Bromine is on carbon 3. So it is 3 bromo, 2, 3, dimethyl hexane. Alright, so the first question was to name it and then state the type of reaction. Clearly, this is a haloalkane. So if you react an haloalkane with sodium hydroxide, then it's nucleophilic substitution. So the first part was to name it. The second part, state the type of reaction when it reacts with sodium hydroxide. So it is nucleophilic substitution. Alright, so the third part of the question asks us for the mechanism. So we know that the first step, this is a tertiary haloalkane, right? The carbon with the halogen, it has 3 carbons attached, so it's a tertiary haloalkane. Therefore, it does SN1. And in SN1, the first step is the formation of our carbocation. So the bond between the carbon and the bromine, it will break heterolytically because the bond is polarized. So the carbon has a slightly positive charge and the bromine, it has a slightly negative charge. right? So the carbon is slightly positive, the bromine is slightly negative. Once you have a polar bond, it will break heterolytically. And so I'm just going to drop up these 3 carbons. So you would get the carbocation as well as the bromide ion. So the carbon to bromine bond, it breaks heterolytically. You get the carbocation and the bromide ion. Then in step 2, alright, so in step 2, it will be the nucleophilic attack by this bromide ion and this carbocation. So again, the bromide ion is donating a pair of electrons, so it must be a curved arrow. Sorry, not the bromide ion, it's nucleophilic substitution. So the nucleophilic attack, it will be done by the hydroxide ion. And so from an alkane, you can get an alcohol. So the hydroxide ion of the sodium hydroxide is what acts as the nucleophile. So in step 1, you form the carbocation because the carbon to halogen bond, it breaks heterolytically. And then the hydroxide ion attacks the carbocation. So you end up with the alcohol. Now on the exam, you would write out the entire structure each time, right? So because of space, I just focus on these 3 carbons. But when you are doing it, write out the entire compound each time. So that's it for the mechanism. It's just 2 steps. From the carbocation, then the nucleophilic attack. So for part B of the question, it is asking us for the reagent and conditions to convert benzene into nitrobenzene, and then it is asking us to do the mechanism. So we know that if we are converting benzene to nitrobenzene, then the reaction is nitration of benzene. And for nitration of benzene, we are going to use concentrated nitric acid and concentrated sulfuric acid, and the temperature of 50 degrees Celsius. So it's concentrated nitric acid and sulfuric acid, that's the reagent, and the condition is the temperature of 50 degrees Celsius. Alright, so we will look at the mechanism now. Alright, so now we're going to look at the nitration of benzene. So with the first thing we have to do is generate the lecture file, which is our nitronium ion. Alright, so to do that, you react sulfuric acid with nitric acid. Alright, and you will get the nitronium ion, which is our electrophile. So in step one of the mechanism, the benzene so one of the pi electrons of the benzene ring is going to attack the nucleophile, the electrophile. So this, the pair of electrons in the pi bond is used to form a bond with the nitronium ion. Now remember, at each point on the ring is a hydrogen, but we just don't show it. So we have hydrogen here. Remember, the formula for benzene is C6H6, but we just don't show the hydrogens, right? So when this bond breaks and you get the nitronium ion added, this carbon, it would only have 1, 2, and the bond with hydrogen, that's 3 bonds. So it would have a positive charge. So where you break the double bond, that carbon, it will have 3 bonds, so you must put a positive charge over it. The carbon with the NO2, it has 4 bonds. 1, 2, 3, 4. Alright? So the pi electron of one of the double bond attacks the electrophile. So we get the nitronium ion added to the ring. And in step 2, let's dry it first. So when you have a catalyst, remember in the definition of a catalyst, you must always regenerate the catalyst. So we're going to remove a hydrogen, right? Now the electrons in this bond are going to go back into the ring to form back the double bond here. So unlike the alkenes, even though benzene have double bonds, it does not do addition reaction, it actually does substitution, right? So it's substitution. The hydrogen here, it is removed because benzene, without the double bond here, or when it gets to the positive charge, it is not as stable, right? So when it gets back the electrons here, the localized pi system that existed before, it is re-established here. So benzene is stable again. So in step 1, the nucleophile is attacked by the pi electrons, and so you get the NO2 attached to the ring, right? Benzene needs to get rid of the positive charge to re-establish its stability. So when it gets the positive charge, it's not as stable as it was without it. So in step 2, the hydrogen is removed, and so the 2 electrons that were in this bond goes back into the ring, and when that is formed, this carbon, it now has 1, 2, 3, plus the hydrogen, right? Remember that? So it has 1, 2, 3, 4 bonds. Once it has four bonds, the positive charge will no longer be there, right? Is when it has the 3 bonds, that's when the positive charge appears. So it has 4 bonds now, so there is no positive charge. So it is 2 steps, right? But another little side note right here, when the benzene forms the positive charge, it will stabilize it by resonance. I can do it in the next video, but this pi bond, it would move up here, right? That would cause the positive charge to come here, and then this one would move over. But I will do that in the next video, alright? But it's not needed for the mechanism for CHEM. So you just show these 2 steps. One where the pi bond forms a bond with the nucleophile, and then the acid comes back and removes a proton here. So you get back the sulfuric acid here, right? So you always generate back your catalyst, and that's it for the mechanism. Right, so for part C of the question, we have a reaction scheme, right? So the question is asking us for the reagents for 1, 2, and 3. So in part 1, we are converting nitrobenzene to phenylamine. So for that, it's reduction, and so we use tin and concentrated hydrochloric acid. So we are reducing the nitrobenzene to phenylamine. So we use tin and concentrated hydrochloric acid. Then for part 2, we are converting the phenylamine to a diazonium salt. And so for that reaction, we need nitrous acid and hydrochloric acid. And then we are converting the diazonium salt to a dye. And so we are, to get the dye, as you can see, over here we have phenol, right? So we reacted the salt formed here with phenol to get our azo dye. So this is a azo compound, right? If I want to say azo dye, so it's a dye, alright? So to get our azo compound, you react the diazonium salt here with phenol. So at 3, you would draw phenol. So it's phenol, so this reaction is called a coupling reaction. So it's phenol coupled with the salt to get the other compound. Alright, so part 2 to this question, it has asked for the name of the compound. So this is the class of this compound. So it's an azo compound. And the use, its commercial use. So it asks about its commercial use. So So we know it is used like in the textile industry, print industry, right? Print and painting industry. So as the name suggests, it's a dye, right? So they are used in these industries because of their bright colors, right? So the class to which this compound belongs, it's an azo compound. It's commercial use, it is used in the textile industry, print and paint industry as well, because of its colors, right? So azo compounds, they are dyes, right? So they are colored compounds. So they uses in the textile, print and paint industries. So that's it for part C. So reduction, then make a salt, then we couple the salt with phenol, and you get your azo compound. I will do the next half of this question in the next video. So since 2019, everything comes as one question, and it's no longer two 50 marks question. So it's just one question for 30 marks. So I'm stopping here for this video, and I will do the next half of the question in a separate video. So that's it for this question. Remember to like, share and subscribe.